This video is on solving quadratics by completing the square. We're going to do 3 examples. It says solve the following by completing the square. Because it says to solve, we have to make sure we read the directions. Because it says solve, if we follow this chart up here, we're not converting to vertex form, but we are solving. So these are examples I've already done. To solve, when we divide by a, we do not multiply back by a. We still have to divide by a, but we don't have to multiply it back. When we would normally multiply it back, that's when we just solve by square roots. We just actually do SADMEP and continue solving. So the first thing we need to do is we do need to divide by a, and we have to move our constant to the other side. So I'm going to do both of those steps at the same time. So I know I have to divide by 2 because that's our a value. So I'm going to end up having x squared minus 5 over 2x plus a box is equal to, I'm going to have to move the 10 over, so that's going to be a positive 10 divided by 2 is equal to 5. Now I'm going to have to plus that box. Next, in order to fill in the box, we take our half of b and square it. So I'm going to have this math over here. I'm going to have that negative 5 over 2 squared, because I have to take that entire thing and divide it by 2. When I divide that by 2, I'm really multiplying by 1/2. So I'm going to take negative 5 over 2 and multiply it by 1 over 2. So this will equal to negative 5 over 4. And then I'm going to square it, which is equal to a positive 25 over a positive 16. So now we have x squared minus 5 over 2x plus a 25 over 16 is equal to a positive 5 plus a 25 over 16. This is obviously not the best type of problem to solve by completing the square, but we have to just follow the directions. Again, the best time to use solve by completing the square is when a value is equal to 1 and your b value is even. So you don't have to end up with all of this. This next part, we want to go ahead and this will factor. This will become x squared of x, squared is x, square root of 25 over 16 is 5 over 4, and we do have a negative sign. Squared is equal to, now we need to combine 5 plus 25 over 16, so I am going to use my calculator for that just because it's just a little bit simpler. So I have 5 plus, I'm going to put parentheses around my fraction, 25 over 16, close parentheses. Now I do want it back as a fraction, so math, enter, enter. I get 105 over 16. So I have 105 over 16. And this is when our directions deviate. Instead of multiplying back by 2, I'm just going to solve from here. So the next step for PEMDAS or SADMEP would be to add or subtract away. Don't have anything. Multiply or divide away. Don't have anything. Exponents. Want to get rid of the square, so I square root it. So we end up with x minus 5 over 4 is equal to the plus or minus. I take the square root of 105 is not possible, so I know I'm going to keep the square root of 105, but the square root of 16 is 4, so I have the square root of 105 over just 4. Now I want to do SADMEP again, so I want to add that 5 over 4 to the other side. So we'll have x equals positive 5 over 4 plus or minus the square root of 105 over 4, which these are the same denominator, so we can actually combine these into 1. So my answer will be x equals, the denominator will be 4, and since it does have a radical left over, we're going to keep it as one set of answers instead of separating them into 2. This will be 5 plus or minus the square root of 105. So our two answers are actually 5 plus the square root of 5 all over 4. Sorry, 105 all over 4. And then 5 minus the square root of 105 all over 4. So again, this was not the best one to use with completing the square, but since that was our directions, solve by completing the square, that's the one we had to use. On this next problem, we want to go ahead and get it back into standard form real quick. So we have a x squared. Let me just write this in pencil. We have an x squared. We have to have our 2x on the other side, so minus 2x, and then minus 1 is equal to 0. Now this time our a is 1 and our b is even, so completing the square will be much easier. So on this one, we do not have to divide by anything because we already have an a value of 1. So we take half of b and square it. So we have our negative 2 divided by 2 squared is equal to, so we have negative 1 squared is equal to 1. So we go ahead and do that. So I know that we're going to end up having x squared minus 2x plus that 1 is equal to, we had to move that negative 1 over. That would be a positive 1 plus that 1. So I skipped that pink step right there. So now we can factor. This is x minus 1 squared is equal to 2. Now we continue solving by square roots. We're going to end up taking the square root of both sides. So we have x minus 1 is equal to plus or minus the square root of 2. And that will not simplify any further. So now we will add the 1 to the other side. And that will end up being our final answer. So x is equal to, we're going to add 1. And we're going to put it in front of the plus or minus. 1 plus or minus the square root of 2. This one was much easier to do because we did not have to divide and didn't have a fraction. We didn't have any weird radicals left over except just the square root of 2, but that was a nice one. And this last example, so on this one, we already actually have our constant over here, so we don't have to put this in standard form because our constant's already over here, and we know that we're always having to move our constant. We do have to divide by 3 to get our a value to be a 1. So we're going to have our x squared minus a 6x plus that box is equal to a negative 10 plus that box, because we already have that constant over there, so that's nice. So now we do our half of b and square it so we can fill in that box. So we have that negative 6 over 2 squared is equal to that negative 3 squared, which is equal to a positive 9. So we have x squared minus 6x plus 9 is equal to negative 10 plus 9. We factor the trinomial, which is x minus 3 squared is equal to negative 1. To solve, we want to get rid of the exponent, so we take the square root. We'll have x minus 3 is equal to plus or minus. The square root of negative 1 is I. This will be imaginary, so it's I. Got to be careful about that. Now we solve this by adding the 3 to the other side, and that will be our, once we get that over, it will be our final answer. X equals, when we add that 3, again, it still goes in front of the plus or minus. So it's going to be 3 plus or minus I. So our two answers are 3 plus I and 3 minus I. That's our set of answers, but we could still say it's 3 plus I, and then we can also say 3 minus I.